1. Okay. On page 311, yes, there is a section review on page 311. Balance the following equations. Number 1, then give the moles of reactant or product below. Determine the corresponding amount in moles of each other reactants and products. Okay. So, one of the things that they don't give you is a starting number, but we'll go ahead and do that here. So, if we have ammonia, NH3 plus O2, I suppose we're going to get some nitrous oxide, maybe, N2O, and water. Okay, so how many moles of pneumonia?
4.
I'm going to say 0. I'm still going to say 0. Okay, but I'm still going to say 0. Yeah. Because why is it 0? Well, no. I said pneumonia. We don't have pneumonia up here. Yeah, it's ammonia. Okay? So here's our equation. Well, that's why it's in smelling salts. Okay. So let's just go ahead and start with, I don't know, 10 moles. Okay? So we want to know how many moles of this, how many moles of that. Okay. So in any stoichiometry problem, you're given the reaction. The first thing you have to do is what? Okay? Balance your equation, and there's really no one set way to start, because when you look at your oxygens, you would notice that they're balanced on each side. We've got 2 hydrogens and 3 over here. So these are odd. Those come in pairs over there. Same with your nitrogen. This is an odd number. You have an even number over here. So just by trial and error, maybe put a 2 there. Okay? So then that gives you 6 hydrogens. Then we would have to put a 3 here. Okay?
And then you need a 2 by your oxygen.
And then that gives us 3, 4, so 2. Not that I doubted that. Just give me a chance to get caught up. Now, is that balanced? Yes, it is. Okay. So, how many steps is it to figure out how many moles of nitrous oxide there are? It's just 2 steps. So we have 10 moles of NH3.
Put 2 moles on the bottom.
Okay.
How many moles of nitrous oxide? All right, yeah, we'll put the
Okay.
2 moles NH3 on the bottom. Your answer is 5 moles.
Okay. 10 divided by 2. Yes, we concur. 5 moles of N2O. So we'll just do the same process here. 10 moles of N NH3. For every 2 moles of NH3, you get 3 moles of water. So 30, I bet you get 15, huh? I can do that math. Okay, fairly simple, fairly straightforward. This is where you will start next semester when you come back. We still have to wrap up our mass-to-mass problems because when you begin this in January, we start with limiting reactants, okay? So,
So you're saying we should probably opt out of the second semester test?
you can do that.
What would be the best decision here?
I don't know, but you had to take a science class, so whether it's this one or another one according to the requirements, but it's not myself that makes that determination. It doesn't mean this is totally accurate, but approximately 90% of the time, your grade is probably either going to stay the same or it's going to go up. Now, that's not to say that this can't be larger and maybe be 4. That doesn't mean that this can't be larger. Maybe that would be 8 and nobody will drop, and you have 20, okay? That's why next week we begin your review for this semester, okay? Which includes scientific notation, okay? Then atoms and moles, well, we're pretty much doing that here, except for we're not applying a mass to it. Then we did electrons, what were 3 parts to the electrons that we did? Bohr models.
Dot diagram.
We did, but that's too far ahead. It's a different chapter. Quantum numbers and configurations. Those 3 things. Okay? Then in chapter 6, then you had your dot diagrams. Then in chapter 7, you're naming compounds.
Will that be on the semester test?
Any and or all of it will. That's correct.
Well, it's a semester test.
That's why it's a semester exam. That's right. Okay? Usually about 20. I don't know. Usually it's between 120 and 150.
Remember when we had 200 last year?
In here?
It's like a regular.
How many are on the biology second semester? Isn't that like 200 or something?
I don't know. I don't remember for sure.
Oh, I remember. There was a lot of them.
Yeah, but you were told exactly what to know, right? You were told what diagrams and what identifications.
That's just like saying, you know, it takes 2 hours to drive somewhere, but you only have an hour to get there.
Doesn't make any sense to me. Yes. Oh, yes. Later on. Okay. All right. So that is practice or section review problem number 1. Let's go ahead and number 3. Acetylene gas, C2H2, is produced as a result of following reaction. Calcium carbide plus water gives you your acetylene and your calcium hydroxide. Okay, so now, this doesn't work all the time, but some of you have caught on to this a long time ago. What is one way to help make this? Yeah, I'm going to say this isn't? Yes. Yeah. So one of the things, keep in mind, Ask any senior. For those of you who decide to reach the pinnacle, organic and biochemistry, there's no math involved. There's just a lot of reaction mechanisms. We say it's all about the water. Your sister could say you would know that. Your brother would know that. Your sister would know that. And your sister would know that too.
Maybe Chase's sister too.
Okay? So I didn't know who said it over here. All right. So the next thing you need to do, balance your equation. So if we rewrite this, you have 2 hydroxides over there and only 1 here. So once we put a 2 there, okay, we've got 2 carbons, calcium and calcium, 2 hydrogens, 2 hydrogens, 2 hydroxides, 2 hydroxides. Okay, so if we needed, let's say, 600 grams of acetylene, how many grams would we need to start with? Okay. One of the things, I don't have your week spread out here yet, but on Wednesday, maybe Thursday, there's an activity over in the lab where you take 2 solutions, okay, and then you mix the 2, and if something or if a substance falls out of a solution, it's called what? Okay, just like rain, sleet, snow, all that falls out of the clouds, that's precipitation, so that's known as a precipitate. Okay, where once you mix the 2 solutions together, a precipitate falls out, so what you do is calculate how many grams you started with and find out how many grams you should be able to produce. Okay, so we take 600 grams of our acetylene. Okay, this is a little bit longer, 4 steps. Okay. Okay, so how many grams are in 1 mole of acetylene?
26.04.
Okay.
No, I don't think that's right. Wow.
Okay. Then this 3rd step, just like in chapter 7, is so important. Why?
To keep track of your.
Well, it allows you to get from this side of the reaction over to here, which is what we need to do. And it's a specific ratio. Okay? It's a mole to mole ratio. Okay? Okay? Once you see a mole over a mole, next thing you do, look back at your equation. Is there any coefficients we need to put in here? Yes. Which one and where? This 2 goes here. Okay? So I ran into some of your senior friends on the volleyball team. They said, we really enjoyed doing this part. Okay? Maybe it's just the crossing off of things. Okay? So we're in moles of water. When you do it this way, it allows you to keep track. Okay?
Right, mole of H2O on the bottom.
We got a mole here, put 2 there, right?
No.
That's something that was observed on your problem evaluations. Some people, and it's a mistake. 2 things. We want you to learn from your mistakes and try not to repeat them. Make sense? So, why don't you just repeat that so everyone can hear that. Repeat what we just said. When it comes to mistakes.
Your mistakes.
Learn from your mistakes and try
Okay,
not to
and try not to repeat them. Okay? These have all canceled. All right.
830.41 grams.
No, Kaylee.
Okay, 830, sure.
0.41.
Okay, again, when you come back from Christmas break, we start with limiting reactants. One of the things, okay, the freshmen will also start their Hidden Figures project. What does that mean to you, Hidden Figures?
It's the movie.
I know it was a movie.
We'll probably start some fair back.
Oh, yeah,
You gonna watch it?
attention.
Okay, in other words, one lady was a engineer, another one was a computer scientist, and another one was a mathematician. Okay, so was this before or after the moon landing? It was before, because this was approximately 'd say had to have been before 1963. Why is that? Here's some of your American history.
First time somebody made it on the moon.
No, because in the movie, they showed a clip of President who? President Kennedy. It says we choose to go to the moon, not because it's simple, but because it's difficult to do. So the moon landing wasn't until 1969. So all this information had to have been before 1963, because President Kennedy was assassinated in 1963. So it had to have been taken place before then. Okay. So when it comes to limiting reactants, if this is what you need to produce 600 grams, okay, what happens if this is 500 instead? What happens to this number over here? Okay? If this is what you need for this reaction to proceed, and if it's not enough, that limiting reactant will keep that from moving forward. In other words, okay, when you look at 5 starters on your basketball team, 6 on a volleyball team, yeah, 3 and 3. Yeah, simple math, okay? So one of the things you could say, your basketball team or the volleyball team is only as good as you don't want to say weakest player. Right. So what happens is a limiting reactant is one that will limit what happens on the other side. And sometimes you work backwards with this. Okay. So got this paper here for you. It's 10 problems. Some of it is time consuming. So as you can see, we know there is an activity tonight. Okay, so tomorrow, what is on your schedule? That's right. Okay. Now, human nature as it is, okay, student collaboration is okay, right?
We can do it all.
But then they still
They collaborate on it.
Okay, because what happens is on your evaluation, okay, wrong answer, over half of it taken right off the top. Daily work's not quite as much, but evaluations it is. Okay? So student collaboration's good, but you've got to make sure that you know why you're writing numbers down and where they belong. Again, here's another thing. We're trying to instill a what inside of you? A work ethic. Okay? We want you to have a good work ethic. Okay. So you've got your paper. You have the rest of the time to work on it. We'll certainly try to point you in the right direction should you have any problems. The rest of the time is yours.